So impressive presentation previously. So thanks a lot. And this is quite a different spin on things. It's more technology focused. So, well, I would like to welcome you and thank you for being here in the hope of basically helping change Africa and the way we do things. I guess I need to acknowledge that obviously this is a challenging time for all of us. We are dealing with COVID and its impact on not just our health, but also on many aspects of our lives today, like jobs, the economy, businesses, well as issues of racial disparity, racism, hate, and polarized political activities around the world. Yet in the midst of all this, we're all come together, which is pretty positive, using sciences, data, businesses, legislative and analytics-oriented people to be the core of the solutions of these problems. So it's a great pleasure being here, and thanks for the invitation. So I'm going to talk about GIS or Geographic Information Systems. Quite a complex word, but it is the fabric that holds information about our world. It's also known as geography, but digital geography or location intelligence, if you're familiar with the term, which is a bit more trendy than the former. This means basically interconnecting people, organizations and activities, sciences, and interconnecting the information through the power of geography, interconnecting our technologies essentially. And it's not just about interconnectivity, but it's also about things like integrations and therefore creating what we call understanding. So our world today is in trouble. We obviously have a lot of problems across the world. These problems are pertinent. They don't change a lot. But it's safe to say that what we've done with environment degradation and issues of social instability has created a lot of uncertainty for everyone. These issues are overwhelming and they are interconnected. So climate change, natural disasters, loss of nature, overpopulation, and so forth. Addressing these issues is going to be challenging for all of us and for basically the rest of our lives. Geography, as we see it, is the science of the world. It provides a way to organize our knowledge. It also helps us interconnect our different sciences and our different disciplines. GIS provides, or Geographic Information System, provides the actual tools or technology of abstracting geography and also the language of organizing and applying the resulting geographic knowledge that our users create, bringing together virtually all the content, every type of content and analytics connecting us, modeling, visualizing our world. And it's also a platform for understanding and then taking intelligent action. GIS provides us with a process, a framework for not only creating this knowledge, but also applying it widely. We measure, we visualize, we analyze, plan and design. And basically, as Richard Saul Wurman says, understanding precedes action. So our users are linking science and rational thinking in the best analytics to action process, as illustrated with the COVID situation, for instance. Now, our users are integrating every data type and format: tabular data, unstructured data, real-time data, vector and raster data sets, imagery data, and they make them available as ready-to-use services in the form of web maps and layers and 3D data. This brings together the world's information as geospatial infrastructure. Now, Arcgis is our core software. It comprises all our products, and it supports three fundamental systems. First, it's a system where a system of record keeping where we store basically all geographical or geospatial data. It's a way to kind of store it in a very efficient manner and retrieve it in an efficient manner. The second system is a system of insights, or is basically a system that extracts these data in a very ordered format that in order to analyze it, slice it and dice it, and find trends and patterns in order to explore and analyze the various forms of richness of geographic information. The third system is a system of taken the output of these analytics and presenting them to again, stakeholders, users, the citizens around our government, around the world, and to tell stories and to gather information in the other way, sort of like a Web 2.0 manner. Now we see different patterns of use of software across all industries. Basically, mapping and visualizing is sort of the obvious one, where to map and visualize different types of data sets. Data management is another one, where we collect, organize, and maintain all the locations in a very well ordered and indexed way from a geospatial perspective. Very difficult data to deal with. As well as field mobility, so apps and apps and maps that help people in the field to not just navigate, which is the obvious thing, but navigate around your assets, but also collect the data and communicate that back to you where your data management happens. It also kind of helps arrange and organize workforce, lots of your hundreds of teams of people within your team that working in the field. Monitoring as well is another pattern of use, where we track and manage, so working with IoT and sensors around the city, around the world, in order to track information, gather it, and place it on a map, but as well analyze it, which is another pattern that we've got. So dealing with the analytical side of things, again, working in trends, finding trends and extracting them to work with them. The design and planning and working on urban planning aspects and things of that sort is a huge part of our software and our products that work in it. Decision support, so things like, again, response to COVID, response to, again, events, things that happen in our day-to-day lives is another aspect that we work with. And constituent engagement, where we kind of communicate this very difficult geographical data that is very complex to users or decision makers to kind of look at it and make sense out of data in a very easy format. Obviously, which enables the sharing and the collaboration piece that we've also got. So typically within companies, organizations, and governments, we tend to see colleagues within the same team, or the different teams, departments, and ministries. We see them siloed and not very well connected. So despite using very similar geospatial data sets, or even very different data sets, that are very related in the real world. However, they're not really connected in our systems. We soon realized that we need an architecture that makes these links and connections in a secure, well-managed, analytical, fast retrievable, and interconnected manner. The architecture is also solution-based, in which the tools are that surround it are based on what the data will be used for, like a commercial business, for instance, or a telco operator or transportation agency. So the tools that help you analyze, work with the data are very customized from a geospatial perspective to deal with the industry you are from or you work with data with. This architecture also includes the ability to have distributed collaboration, which means servers from all these different departments or different teams or different even ministries. Means they can all reside in multiple places with their own specialized data sets. It allows the layers and maps and other content to be shared amongst 2 or more enterprise portals, so different portals for every organization or every team or every even individual, extending the reach to GIS content out not only inside the organization but as well externally if required, which kind of helps the distributed collaboration side of things and search and discovery of data and maps from contributors within your own environment. So a prime example of that is the government of Abu Dhabi. So we've worked with them over the past 10 years, maybe. We've helped them create what we call a spatial data infrastructure, or an SDI, through which geospatial data is managed, shared, and analyzed across different government organizations. In this case, 73 organizations and ministries, to be exact. And within each organization, using the relevant access control rights in order to share the relevant data with each other or within even the organization itself. This resulted in an ease of creating apps, what you've got on the left of the screen, and addresses aspects such as food security, urban planning, business growth for all the businesses residing in the country, in the city, using artificial intelligence or AI for many endeavors and so on. Now, just to give you a small brief of our world, so our users come from different fields, but are using common technology and similar methods to accomplish very important work that makes our world better. The next few slides will be basically a more of a profile of this important work that our users have achieved over the years. Some of our users are working in the environmental monitoring and modeling and assessments. For example, monitoring weather in real time in Japan, or tracking whales off of Alaska, for instance. The interesting map in the center shows the biodiversity in the Antarctic. Some of our users are working on assessing the impact of deforestation in the Amazon, and others are creating new integrated landscape approaches for bringing it all together in a sustainable way. For natural resources management, examples on the right show our users work the users that work in the field, in agriculture and aquaculture. The examples in the top right shows, for instance, GIS being used in managing the movement of honeybee colonies across the US every year with the help of pollination. In the bottom right, for instance, you can see an example of sustainable forest management planning in Brazil. And in the upper right, you can see work on creating renewable energy. Here are other few examples on how our users work in managing land information, organization of property rights, who owns what, which is central to a civilized society, obviously, and to modern society. Core problem in Africa from our experience. And we think about this as a system of record keeping, but not just that. It also looks at interesting examples on how it could look at things like taxable property value and what's happening with subdivisions, or in the upper left, well leasing in 3D, for instance. Many of our users are working on creating our future. So this means urban design and planning when we're building cities in lots of places in the world out of the desert, in some cases, as we see in the Middle East, for instance. The example in downtown San Francisco is showing urban design of buildings. The work in this area extends to basically finding housing for the homeless, as in the example in Los Angeles, or this great piece of work in Jakarta of interactive community planning, making the planning process more inclusive. As you can see also on the right, GIS has moved into buildings and campuses and cities to visualize them, like this great BIM model in the bottom right, for instance, brought into GIS for visualization, as you can see. And basically this kind of helps with all the assessment of BIM models and how they fit into the bigger landscape. Visualization is only the beginning, though. GIS is more used for indoor space management, things like analytics and navigation. For example, Harvard University has routing from building to building, from room to room, using our technology. A lot of very, very good work, but again, as I said, this is the basis of everything to start. In the field of transportation, users are not only interconnecting and basically using the fabric of the interconnections. They are looking at powerful things such as accident analysis, understanding what causes accidents as well, and predicting accidents in lots of cases, being able to detect problems and then fix them as well. Some are working on highway operations, looking at dashboards and what's going to happen in real time, looking at railroads and lightning strikes, for instance. Using AI and machine learning for object recognition, for example, like an example here in Germany. You can also note that the command and control dashboard in the bottom center, that basically displays data from literally every sensor on the roads of the city of Hong Kong. GIS is also extensively used in water and watershed management. Users are shown water consumption and water quality spatially using dashboards. They're also analyzing what areas need water, main repairs, for instance, managing field people and doing lots of analytics based on that. Other aspects is utilities, big area for us. Utilities of all types, such as electric and gas and fiber, are now supporting a complete network lifecycle using GIS, from things such as network design to management, and then planning for the future. the sliding green in the middle shows the network availability, which is of particular importance at the time when kids have to stay at home because of access to internet that can define digital divides. Movement analytics in the bottom right, for instance, has been a major area of work for us in the past few years as well, while working with telco operators, as you can see in the United Arab Emirates or the UAE in the bottom right, for instance. In the field of public safety, again, there's been a lot of work done, such as crime analysis, event monitoring. In the bottom right, for instance, you can see the Hajj in the pilgrimage, the Muslim pilgrimage in Saudi Arabia event being tracked live and orchestrated with more than 3 million people taking part in the event. And obviously, as you can see in the center of the screen as well, the Boston Marathon, after the sorrowful events that took place a few years ago, we've been monitoring the event every year from there on and identifying, again, things like movements, suspicious movements, anomaly detection, and so forth. A disaster management as well is something that we face in our everyday world. Some of it is caused by climate, others are just naturally occurring. For example, in Japan, monsoons are causing flooding with water, with just water that is just 10 meters deep. The work of GIS professionals is helping to respond to these disasters, from typhoons to earthquakes and fires. Look at the map, for example, of the Amazon fires that were damaging and wiping out landscapes last year. And identifying these patterns in real time really helps with decision making and tackling these in real time. Remote sensing, one of the core things that we do, which is basically based on satellite imagery and taking that satellite imagery, doing things with it like feature extraction from imagery, working with different bands of color that you've got in imagery in order to analyze it and extract features from it, building footprints, for instance, and other types of features. Other things are such as, for example, dividing agricultural land, for instance, detecting changes. We use a lot of artificial intelligence, or what we call geo AI tools that kind of help us do that. Imagery is becoming more real time as well. So we've got a lot of aspects such as tracking ships, tracking other aspects using imagery, but as well, you know, working with drones and all these kind of sorts of cool technologies that have been out for the past few years. We've leveraged that a lot in working with imagery and performing analysis based on that. Now, business, one core thing that we work on very, very heavily, GIS is very heavy on it. And businesses are obviously have been waking up to this power for decades now, to do things such as site selection, meaning that what is the best location of distribution centers, for example, to deliver to the right end sale points, or bank branches, for example, where to place our bank branches. Spatial autocorrelation for banking customers whom are likely to take up a mortgage close to a branch, for example. Territorial market planning, for instance, based on historical sales by using things like geographic regression, so understanding patterns of the social demographics in a geography and drawing up regression models based on that. Also in the part of real estate, and working a lot in that field to grow and find where businesses can grow. Obviously, you can also see an example of GIS being used to show businesses that are open during the pandemic, something during our one of the things that we do during the pandemic. Lots of other applications that have come up over the past year for COVID and how to tackle it. Which brings me to, again, things like census collection. A lot of governments around the world use us for storage and analysis. It's a core solution that many of our users work with. The 2020 US Census, for example, is a prime instance of that, where it has been carried out with the help of GIS and geography. You can see a few examples displaying census information, very interesting work across the board, across the world, and within Africa itself as well. In the area of public health, which is our last kind of couple of slides on focusing on public health, the application of GIS again shows a lot of disease trends like malaria and African swine flu, as well as relationships and patterns. You can also see examples of GIS being applied to an issue that's on our minds today, which is social equity, racial and ethnic disparities, social vulnerability, Again, access to food stores, health facilities, and so on. GIS is making very interesting maps, but it also kind of helps us to understand and portray that understanding to lots of people around the world, which brings us to, again, the dashboards that we've been building for, or lots of governments around the world, lots of entities, even businesses have been using our software to create these dashboards for COVID times. And all these are they've created there are thousands and thousands of dashboards around the world. You've seen probably some of them on the news. Some of these dashboards are very focused, like an executive decision support, shown in the Baton Rouge, for example, and others are open for the public and to see what's happening across the country. Hospital admissions, patient statuses, cases, deaths, recovery information. The maps on the lower right, for example, are showing operations dashboards, like what's potential impact of COVID on operations in the US, and to help the US Army Corps, for example, of engineers to tackle and the impact of firefighters' work and so on. Which brings me as well to the response. So now that we have response and we have vaccines being deployed in different places, how to prioritize these vaccines, how to target the right areas in the right places, as well understanding the hospital beds and the response aspects, so understanding the details of the ICU beds, like in the right bottom, seeing ICU beds and the available staff. Doing sidewalk analysis, social distance in London, for example, and in Jakarta, they are using statistical analysis and spatial-temporal analytics to find hotspots. In the US, lots of interesting maps have been created by Johns Hopkins show on Spread, and you've seen them featured probably over the news a lot over the past year and a half now. You can also see maps detecting testing sites and picking the right location based on travel time and understanding vulnerable urban populations. I mean, it's a moment of pride really to work with all these organizations around the world in order to help to, again, measure the effect of COVID and to try to tackle COVID in lots of ways. But it's been as well quite a journey to kind of tweak all the software in order to focus on the pandemic and during the past year. So just to let you know, as a closing, we obviously have a huge partner ecosystem with thousands and thousands of partners around the world. This is just a snapshot of them. Some of them are very largely integrated with us, like cloud providers and others. Some are smaller organizations or smaller integrations that we work with. But again, it's a huge partnership kind of ecosystem that we work within. We focus very much on education. We have programs for higher education that licenses our software to institutions, departments, and students. We are also making LearnGIS sessions, which is our platform for teaching GIS, available to all students for a year during the pandemic. There's a lot of schools and good work that comes out of the education ecosystem. In conservation as well, ESRI supports thousands of NGOs that are working to understand and protect our nature. So with this, I'd like to close and thank you. Sorry for overrunning my time a little bit, but thanks a lot for this kind of invitation, and hopefully would have transmitted or given you a small taster of our world and the cool things really that our users do. Thanks.